in this book. I'll roll back and say, okay, so air conditioning, wire, components, and circuitry. That's what that was trying to lecture like, but this is what the components look, and then when you go over the electrical connections, that's what it looks like. So all of these chapters kind of connect, that's why it's components, electric circuitry, and sometimes we mix them in order to get a better understanding for the students. Instead of splitting, I take both books and put it together, and I say this book does a better job in chapter 5. So I'm still want my 17, I gave 14. And I got a few of them because I graded them, but it wasn't enough to cover this class. So I just go, oh well, keep going. Any questions about that before we do this? So since I'm hearing so much about motors, let's go to unit 5. And then that backs us up, and then we'll get more complex in how they work. Let's first just talk about this. Because I have to slow down a little bit, because I normally teach higher up classes, and then I have to catch myself. So this is the beginning class.
Yeah, I think that's what you're doing, sir.
Yeah, and everybody
I think that's what you're doing, sir.
You know why? Because 3 weeks ago, a student went over to the dean and said, he ain't teaching high enough. I said, okay. Who the hell said that? Yeah, 2 of them over there. He ain't teaching high enough.
We just wanna learn.
And so I come back to that class at night, I say, I'm gonna tell y'all something. Welcome to Georgia Tech. Never ask me to teach lower again. You better hold on tight, because I'm not slowing down. They was in there looking sad last night. I said, I got pump tissues too, if you need them. But 2 of them, guess what? 2 of them get it. 2 of them get it. So it shows that what it is people learn on different levels. So I want to go to this book, chapter 5. Components, symbols, circuitries of air conditioning. When we say circuitries of air conditioning, I like to say circuitries of HVAC. It's the circuitry is what? The wire. The circuitry is the wires. And it also, when you talk about the whole system, you're talking about the mechanical side and the electrical side. The electrical side is 80% of all problems in our industry. Electrical side is. So the electrical side, how we will say is, I'm gonna make it for y'all. The electrical side has relays, contactors. We're going to take it from the beginning. Relays, contactors, switches, coils, and then these are the basic functions, and control board. It has control boards. It has power source. And it has line voltage, can vary. And it has secondary voltage. We'll define all of these. And we also mentioned that there is a transformer. So the electrical side, and we're looking at this as components. HVAC, electrical side,
gonna define what relays are and how they work, and then we'll be able to move forward. There are relays and there are contactors. They are both electrical switches that in order for them to work or operate must have a low voltage in our industry of residential of 24 volts. Now the 24 volts does us no good unless there's a characteristic of a relay and a coil that allows it to function in order to move. It must have what? See if you remember. We know it's 24 volts, but 24 volts is just 20. If it doesn't have a coil,
then it can't do.
it does not create magnetism. If we can't create magnetism, we can't create motion. So the motion is a movement. In a relay and a contactor, the motion is open and close contacts across the switch. Because a relay and a contactor are both switches. That's gonna be our little switch sign. They're both switches, but switches with coils. A relay is normally on fans or smaller load components. A contactor is a heavier load component, like compressors, more powerful fans. It can handle more amperage. So a relay is about 28 to 30, as many milliamps as it can take. When you get bigger, we get to that in the book, as the load increases, we have to increase the kind of contact we use in order to handle the load of motor, compressor, or whatever's load. Do we understand what the load is when we're speaking about electrical? Because we have other loads when we talk about manual J. So our industry crosses what words mean. Because, and this is gonna simplify it for some people too. So when we talk about air conditioning having a evaporator or condenser coil, this could be confusing to you at first. But when we talk about electrical coil, we're talking about the coil, the electrical coil, as we call it, resistance coil that's on a contactor or relay. It could be in a gas valve, because if we put 24 volts to any kind of component and we want it to have an action of movement, it must have a coil to generate magnetism. All coils are not the same resistance. It is designed for the resistance and the voltage and the amperage it needs for that particular component. So if it's a coil, we want something to move for a particular purpose. For a contactor, why do we need a coil? For something to move, what are we trying to move on a contactor?
The air?
We want the contacts. Do you know what contacts are?
Yes.
They may not. So when we have a relay or we have a contactor, it has contacts. Contacts are the physical components that's in a relay or contactor that make connection points. What does a connecting point look like? Okay, so if this is a contactor, for an example, and it would look on both ends, because we said on our contactors, where we'll say, when we have a power source, and we start with a power source, what do we have? And that L2 could also, in some circuits, just be in. So when we have a contactor, for example, then this would be L1 at the disconnect. What's a disconnect?
It's the box of.
It's an off and on manual switch, mostly within 5 or 6 feet of the equipment you service. So you can service it without going in the house and running in there, shutting off a breaker and come back and then somebody turn it off. You operate it because it's right by the machine and you shut it off. But that is, from the disconnect, where does the disconnect get its power source from?
The breaker.
The breaker. Main breaker. Main breaker, and it has to have an amperage that supplies the load that's on the other end. So for a furnace, it has a different size breaker, usually about 15 amps. For outdoor unit, it may have, depending on the size of the condenser, 40, 50, or more amps, depending on the tonnage of the unit. So the amperage matches the load. You need to get that. What is amps?
Power.
What are the amps? Write down amps. You need to know that. Write down amps. Load. Amps, loads. Amps are on every type of equipment or component that draws a load. What is a load? The what?
Power being used.
Current. The current.
So if I look at this motor,
That's a load.
because it has a coil, we require it to move, then it has a load. The load is based on what force we're putting on that shaft, the stator, the rotor. What does the stator do? Does it stay still or move?
Stay still.
And you know how you remember that on quizzes?
Still.
Stator starts with S, it stays. Rotor starts with R, it rotates. So when the magnetism increases across the coil, you get rotation. That's simply spoken. But on this motor, it'll tell you RPMs, voltage, 115. It'll tell you that on this motor, it is 60 hertz, and it'll tell you that the amps is 1.6. That's not a lot of amps. This motor doesn't have a capacitor on it, it's a simple motor.
So amps is matches loads, let's go.
Amps is a word that you guys are gonna define and turn it back into me. If I write it in that square, because it's necessary for you to know. It's necessary for you to know. And it's easy to find in that book. Amps. Does your meter have an amp?
Yep.
Address amps?
Mm-hmm.
Because amps can tell us some things. But first you have to know what it is, and this is part of your assignment, to make you understand it easier. Because if I have 1.4, once you understand what it is, I'm gonna tell you how you use it. If I have 1.4 and I'm troubleshooting, like the gentleman said, sometimes you can feel the back of a motor, and if it's real hot, it shouldn't be real hot, right? Because these vents cool that motor, those are air vents. Keep that motor cool, but a motor can draw high amps or over amp for a variety of reasons. The shaft could be starting to lock up. Some of the windings could start failing. It could be a restriction, and we put our amp meter on one line, the voltage, and it'll give us an amp draw. If the amp draw was 3 amps, what would that tell us when we saw 1.8?
Drawing too much.
Drawing too much is some kind of restriction, or the motor is starting to fail. So we know from one point of troubleshooting, we can start here. If the blade that is inside is impaired or held up, that any restriction to airflow, any restriction to movement, birds get down in there, all kind of, weird things happen inside those blower motors, it would draw a high amperage. Because it's designed to have a free flow. How many flows did I tell you? I'm gonna say it forever.
4.
What are they?
Air pressure.
Not pressure, air,
Refrigerant.
refrigerant,
Water.
water, and
Electric.
this, electrical. So sometimes it could be 2 or more, or I know for certainly 1, because if we get a restriction for air and the rotation of the motor cannot force against the load of that blockage, amperage rises. Amperage rises because it's designed for a certain flow of air, it is designed for clearance, and it is designed for the shaft to spin freely. That's why we look at nameplate. Do you know that's nameplate data? This, on every component, there's a nameplate data, unless JoJo scraped it off. Nameplate data gives us, look at it, gives us everything about any component. We're not geniuses. We don't know how to pick this stuff up. We're not geniuses. Nameplate data is on everything. 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 Nameplate data is on everything. So for right now, when I give these to you, you write down on your notes the nameplate data, whatever's in your area. Y'all got that one? Nameplate data. Write it down, because you need to know how we gather information. Every piece of equipment should have nameplate data. And we don't have to be a genius. Anyone, you can use that one. And write it down, whatever's on that little tag, that white or silver tag, write it in your notes. And say nameplate data. We're gonna be using it all in the trade. Nameplate data. That's another word. That's important throughout this entire trade. Sometimes it always gives us voltage, amperage, RPMs, CPMs. It'll give us information for rotation of a motor, if it should be counterclockwise or clockwise. Sometimes they give us some information of how you could change the direction of a particular type of motor by taking the 2 additional wires. Sometimes they could be yellow and purple, brown and yellow and purple. It could be different color wires. Sometimes it's 2 yellow, 2 purple, and if it's yellow and purple, it could be clockwise. If you mismatch it, yellow, purple, the same motor can go counterclockwise, so therefore you only need 1 motor. You put it in the direction that you want it to go. Just like multi-tap. Any questions on that? Ask it now. Yes.
I'm looking at this data, see what class B and type in.
Different classes, class A, B, C, is describing the characteristics of that motor, how it's made, how it fits, how it's sized, how it can take heat, what type of wires in there. Each one has a class to it. And when they look up the parts at the part place, they'll know what it is.
So which number we looking at? We looking at the type.
When I look at this, I would say, first of all, it's a Fastco who makes a lot of motors. And I would look here, I don't need to know where they're located. I would say, okay, that's the model number, the voltage is 115, the 60 hertz, the amps is 1.6, RPMs is 3,500. And then that is, what is that? That's the pin or the manufacturer's model number if I were to order that part. They type it into the part index, and they'll pull that part up, always open it up and compare.
So we really just got them at the first the number and the volts and hertz.
Because you have to know the volts, don't you? One of these motors look the same and one is 220, 240. You must have a part that works for that particular machine. That's one of the first identification pieces you need to know, or we need to know about a component.
So there's some numbers on there, one is their number, and one is a customer number.
Sometimes it could be a part number for the manufacturer, and sometimes it could be a universal model number. And sometimes if it's a motor they make, the manufacturer makes for a particular type of equipment, they're gonna ask for that PIN number. And that means you gotta buy that from them, you can't go nowhere else and get it. That they are OEM, original manufacturer part. Any other part won't work. That's residuals in their pocket. So what's the question here, sir?
We can't read our nameplate data, it's too,
It's too little?
it's just,
Is it nasty? Like reading? This one is going to be, that's just a warning sticker, but it's down here. It's a VR8 205H601. And it's 24 volts. Sometimes you gotta get that angle thing on it. You gotta get that angle. See, like here, I can read it.
you can?
Yeah, I can read it, cause I'm used to looking at it.
What is the name?
And is that black one giving you any? 9540. So this one may be difficult, but it is a 24 volt valve, and it is a VR8. That's the first numbers they need. It's a VR8 205-4601. And I give them that number, they'll pull the exact valve out. It's a Honeywell. But that's a good point. Sometimes you can't see it. Then you're gonna get the furnace model number, and then you're gonna go online, and we'll do that in class, how you search for a part. Okay, so y'all can switch. So
That's the name?
that's White Rogers. White Rogers makes a lot of controls with Honeywell as well.
This is control?
This is a transformer, a low voltage step down transformer. Input can be 120, 208, or 240 volts, 50-60 search. Common is black. 120 volts is white with the black wire. 208 is the black wire with red. 240 is the black wire with orange. So on this case, common doesn't mean that it's a neutral leg. Common means it's the other, it's the wire that you put with whatever speed you want. So they're saying on this particular one, common is black, and sometimes common will be white. And you have to pay attention to
Let's
what
read this, because it's common as black on this one.
it tells you.
Yeah.
And sometimes students burn up the transformers. I said, did you read it? Well, I put the white wire there. What did they tell you? And you look at it and say, common is black.
The second number is underneath the White Rogers. What is that? Is this just the type of this?
It's explaining the type of contactor it is. If you're looking at the model number, it lets them know out of the many transformers and components they make. These identify, sometimes it identifies the class type it is, it identifies the year, the month it was made, and the voltage and everything. They can tell when that motor, where it was made, or that component, where, by those model numbers or serial numbers. All right, who else has a question on that information?
Monday we do that.
Okay, so nameplate data, loads, and
What's the
amps. Yes.
Can you tell me the words for this one?
This is a what?
Capacitor.
Capacitor.
And you said this morning, what does a capacitor do?
There's gonna be a starter run capacitor that starts the, gives the kickstart.
For provides extra torque. And it stores energy. And if you touch this without discharging, you will feel the stored energy. So you discharge it, not with a screwdriver, even though 95% of all techs do that. You discharge it with a 20 ohm resistor, and it removes the charge on it. That's the correct way.
Before you install it,
No, after it's been installed, because if you take it out and you check it, and you put it back in, it's charged, and you take it back out again, it's charged. You gotta discharge it again. You put it back in, take it back out again, it's charged again, you have to discharge it. Every time you power it up, it's charged, because that's what it does.
How long did it take you, you gotta keep it to discharge it?
It's discharged,
Soon you do it one time?
discharged. That's why techs have bad habits and they take a screwdriver and go like that. It's discharged. You see a little spark, but you shouldn't do that. Yeah, it could damage you.
Are they,
What the correct way you do it?
With a 20 amp, 20 ohm rather, resistor. You can buy them in a bag as a tool for about $3. And you take, bend the probes and let it touch like that, and it's instantly
20 ohm
discharged.
resistor.
These are handy, these are.
they all
Requires,
ask
I
a
hold mine
question,
requires
right?
a bend it and just touch it. Some people use alligator clips, clip it on one side, the other side, and then just clip the elevator, clip one elevator clip on, or just take them over the hand and go any way you want to.
Could they be, compared or like, compared to like a battery?
Only in that it stores energy, that's it. These are microfarad. Microfarad. You will see it two ways. So you aren't confused. Some manufacturers do it that is the symbol, UF for microfarad. Some people just say that's too complex, just put MF and it's microfarad. That's what this is, it's microfarad. And so it's rated, it has a model number on it. This is made by Dactyl, and it is a 35.5 microfarad, 370 VAC volt amp current. So this is a dual capacitor, right?
Hey, what did UF stand for? The other one, microfarad, what's it?
What does the UF stand for? The S and the X?
Where you at?
The U, what is it, U?
You are?
UF or MF, so the UF, the MF is microfarad.
That's microfarad
They're
too.
both on.
These are two different symbols for microfarad. Different companies, remember I said you can use any symbol you want.
Does it have
So it could be a GE and they might say, we just put microfarads, this is a GE, and they're using UF. So if it's a, does that answer your question?
Well, that's the acronym, doesn't mean that you didn't specify.
It doesn't matter,
Okay,
it's the same.
same.
So you could look at a control and say, I don't see UF.
Michael,
Farad,
what was the question?
farad. It's a measurement, microfarad is a measurement like ohms, like voltage, like amperage. It's a measurement. And if they say micro, is what? Small. So 3.5 and 35 microfarads, 370 VAC, commonly found on a 3-ton air conditioner. I know because I just did so many of them.
Did you try to print something? It was showing paper empty last night.
Paper, what it say?
Paper empty in
It said that for 2 days. I don't know what's wrong with that thing. It's packed.
full.
I done turned it off, yours printed?
Yeah, mine's printed, but you know.
Mine just ain't printed. So I don't know what the deal is. You know what it might be? I need to check my printer. Cause when I was in registration, I was printing from their printer. And it might be looking at a printer that's on that desk saying it's empty. I may need to check that.
Yeah.
Dang.
It is what it is.
Yeah.
Okay.
You're back.
A dual capacitor, dual means what?
Go.
So it means 2 in 1. So in order to, instead of having one for the fan, one for the compressor, man, that cost me a lot of money to make this as a manufacturer. So the new electrical engineer said, he was the new electrical engineer, He was eating potato chips, and then he looked up and said, hey, I can make a dual capacitor, save us 200 million a year in production.
Yeah.
I can make sales on both sides, and they can share a common terminal. A common terminal. So I'll make sales on one side that says 5 microfarads, and 5 microfarads will always be the capacitor for the motor. 35 will always be the capacitor to the compressor. Well, how will they know? Well, besides them taking their meter, going down from common to each side, it will identify what side is 35 or 5. But they don't make us work that hard. They put a fan, some people got cheaper, and they just put F. Well, boss, I can save 300 million a year by just taking 2 letters off and just put F. And on the box, F stands for fan. And the other one says HERM. What is HERM? Short for Herman? What is HERM? Hermetic. HERM. Hermetic compressor. A hermetic compressor is a sealed compressor. There are no bolts, there are no screws, you cannot fix it. It's a toss and replace item. That's what a hermetic. They're put on items that are, to make them inexpensive, like your home refrigerator, anything that's kind of inexpensive, as we would call in our trade. You wouldn't want to put a semi-hermetic compressor in a refrigerator at home, because to replace the compressor might cost more than a refrigerator. It might be $2 grand. So home refrigerators are tossers. Everything on it's plastic. You either have motors with no capacitors in the evaporator, all of that. It's tossables. Some people fix them, but they're tossables. So it is possible with the dual capacitor, which does what? What does a capacitor do?
Deals with 2
It gives them more
capacitors.
Whether in this case, if it's fan or compressor, it's for 2 different items. Here's the cool thing about this. You could have a service call and the compressor's running and the fan won't run. So we're talking circuitry. So what does that tell us about the power that would be on that contactor? What does it tell us? Fan is running. This is a dual capacitor. I'm trying to get you to start thinking and analyzing. This is called follow the wire trace. It ain't difficult. We said, whoever has it, when the contactor closes, when it closes, L1 and L2 coming from the power supply, then we also have a L1 and L2 that is also on the contactor. Of course, we got 24 volts on the side, and I'm gonna do that different. And on the bottom, it would be what?
T1,
T1, T2. And so I make it simple by saying L1 is a line. That's the actual power lines coming to that component. It was L1 when we left here, and L2 was L1 and L2. At the disconnect, it's L1 and L2 at the contactor. Same L1, L2. However, that's the supply. When we go to a machine and the switch closes, L1 and L2 become what? Why?
It's not the same thing.
Why? It's simple.
It's the same power.
What did I say T stands for?
To go to something.
It's going to something. So it is going to what? Something that runs with a coil in it? And we'll call this a motor. But the motor doesn't get the same voltage. If this L1 and L2 is 240 volts, then what should T1 and T2 be when it closes the contacts?
half of each, 120 each.
On each side, what should the total be? 240. So that means that motor that you read on that diagram nameplate better be a 240 volt motor. Cause that's what's gonna happen when you close it. Now we also have one of those wires going to fan 1 on that component. But let's talk about the contactors before we move that one. These are normally open contactors. All that space in there, there's no contact. If it's no contact, there's no T2. Does that make sense? Because the contactor has to close. If there's no L1, L2, there's no T1, T2. So therefore, a closed contact looks like this. That's what a closed contact looks like. So now L1 and L2 will have the same voltage. If it doesn't, and it closes or seems like it's closed, which they can on rare occasions, something mechanically has failed on that contactor. Whether these contacts, which are here, have fouled down and created a space. That's a hard one to catch too. Because you look at it and go, hey! You're like, it's good. You don't have any voltage. They can actually foul down the contacts. Another thing is physically, because that means that the coil is what? If it seems to close. Coil's good.
Yeah.
It closed, but it must close tightly. It must close tightly in order to make L1 and L2 convert to the other side, la 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 la, here, from here, and become T1 and become T2. Does that make sense?
Yes.
If it doesn't make sense, say it don't make sense. Just because it makes sense to me don't mean it makes sense to you. I've been doing this a long time. Okay. So, contacts can wear down. And I'm telling you this because I said, if it seems like you put 24 volts and go click, click, and you see it move all the way in, you're like, I don't have no T1, I don't have no T1 and T2, that means it's not a connection. It's not gonna be a connection between L1, L2, and T1 and T2 unless the contactors are what? The contacts are what? Made tight together. So, well, what does it look like when it's not tight? Why is it, and it also can show you low voltage if you have some voltage from T1 to T2. You're looking on a 240, what you looking for T1 and T2?
240.
What if you have 50? You're like, what? 50? This actually happens, so you need to know this. I don't even think it's in the book.
Contact's not made.
Is a gap between?
Not a gap this time.
Small contact.
Those are little spikes. They represent when power goes on and off, like click, 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 click. It can arc like welding and make little rises like stalactites and stalagmites. You know what that is?
Yeah.
Like ice that sickles and hang from a cave. You see them in movies.
You said they represent what? I'm sorry. You said they represent
Spikes.
but what-
Arcing.
Okay.
It is arcing like a welder, an arc welder. And anytime it arcs on a contact, any contactor, it can destroy, the arcing can damage and destroy the contact. So why does it show 40, 50 volts from T1 and T2? It shows 40 or 50 volts to T1 and T2 because part of the little metal sickles are touching. Not enough to get 240, but it is enough to get some reading. And that's what that is, when you see that. Sometimes they can get carbon built up and damaged. Sometimes, so we're talking about why you might read some variables. Sometimes between the contacts, you may have, you might have a what? Talking about the doggone Valentine things I took down. It's over. So, what is that, a B? It could be a B, it could be a spider. you remember this. Bees, spiders, ants, often, they will be there this spring when you look at them, will get between the contactors. What did I tell you? If the coil is good, what would the contactor do? Click! And it's going all the way in. It looked like it doesn't. But ants get in there. I don't know why they are attracted to magnetism. They'll be in there. Sometimes it'll be a few, sometimes it'll be thousands in there. They'll be all down there coming up and all in the contactor. And if anything gets between the contactor, does power transfer from L1 to L2?
No. Yep.
So if a bee gets in there, if a spider lays eggs in there, this is real stuff.
Spiders, how many spiders? Cause I don't do spiders.
I don't do them either, but if they there, you're gonna see a lot of that stuff in our business, and I carry Raid 15 feet. And it works. The worst, you might have bees in there. Everything is attracted to that panel that we have in there. Can affect the operation. Once in a while, you'll find a lizard in there, a little tiny lizard dead. Sometimes you'll see a giant rat in there dead. Because if Mr. Rat bites L1 and L2, is that a good exterminator?
Yes.
History.
Great one.
History. So I'm giving you some things that can impede contactors from working. And when we say working, there's two different kinds of working. One type of working is the electrical that goes from low voltage, which is the 24 volt side, that the magnetism closes and pulls the relay closed, that allows L1, T1, L2, T2 to connect to a motor, and it is action. Anytime we close a relay on the leaving side, there should be action. Well, why would we want to close it? Action, a load. Does that make sense? You need something else for it. It's gonna get better. Don't go to sleep on me. It's gonna get better. I have to make sure you know this before I let you loose on my machines. I didn't know that happened. Oh, yeah, it did too. Loads, source, switch, load. What are the four components? Wire, source, switch, and load. Source is the voltage. In every circuit, basic circuit, wire to connect to, like in lab, source, which is the energy. A battery and a flashlight is a source, power source. A switch on the flashlight. I don't want to burn the battery out. They're about $17. Turn it off. And the switch interrupts the power source so that the load doesn't drain the battery. If you didn't turn your car off, you're gonna drain the battery. Any questions on that part? Okay. So, next, and it's kind of a review before I give you a quiz. So, today, maybe not. Switches. I told you already, switches only do two things. What?
On and off.
On, off, open.
Open, close.
Okay, so we're on, off, and we open and close. What are we on for? To energize or what?
No.
Oh man, y'all said it, I'm so happy. To energize a load. So, open, close, on, off, and you may hear some people say, energize, de-energize. Means the same thing. That's what can be confusing. about language. You might say, why don't you just say open and close? Why are they doing all that? Energize, de-energize, on, off. That all means the same. Sometimes it just sounds better on an interview to say energize and de-energize. Make you seem kind of smart, don't it? Energize and de-energize the circuit.
So close will be like the magnetism.
Close would be,
Yeah.
okay, so that's a good question. She says, will close be on and off? Close can always be on and off, but on and off, that's why we're doing it this way. On and off, different ways. On a plain manual switch, on and off is what? We're the operator. We're not paying anybody for no fancy nothing. If I want my TV off in 1960, or if you had kids, they don't turn the TV off. Change the channel. I was change the channel. We didn't have that. I was changing that. I wasn't going to change the channel. Keep going. I'll tell you when to stop. It was only 4 channels, so you didn't have to do but 4 clicks. And then sometime I had to be the antenna. Got an antenna, didn't have cable. I love technology. But we'll get some foil out the kitchen and put it on the antenna. Turn it this way. Take your hand off to go blurry. Put it back on, it's perfect. So now I'm the channel changer and the antenna. Anybody born in that time, you ask them, they're gonna tell you that's the truth.
What year did it change?
1960.
Boy,
1970.
probably wouldn't know because I wasn't in a house that believed in spending money on this. Well, I don't care what they have, go change the channel. You my channel, come here. Change that. So, I don't remember, probably 70s.
Yes, 70.
Probably.
About 74.
Probably 70s. And color television came in maybe in the 60s, but it was awful. The first color television had a wheel and point, and it had red, green, and yellow, and it added a dingy color, and we was like, ooh, color television. So electronics came a long way. Next item. Ain't no break time, it's too early, it feels too early.
Never too early.
15 after 10.
Oh, you still got
15 minutes.
17. Coils, switches. Switches open and close. They can be manual, but because we didn't want to be the channel changer, that's where I was going with that, we said, I want it to happen automatic. So how can it happen automatic? You can have remote, or how can, if we introduce, say for our contactors who take L1 and L2, and you could take someone and touch the wires, make a rig to touch both of those wires that are from L1 to L2, T1 to T2, it would run. But every time you were satisfied, you would have to hold your hands apart. So then you said, okay, I'm gonna run a long wire. Now when we're satisfied, I'm gonna shut it off. Cool, I don't have to do it. I can do it from a distance. Then you got tired of doing it and said, how can we do it?
Jump.
So we don't want to jump no more. So this young man said, you know what? I've been in the garage and I invented a coil. What is that gonna do? Well, it creates magnetism, and the same switch, it allows the switch to have a mechanical linkage, and it goes up and down, open and close. I could put 24 volts on it, and it'll energize, close the switch, and it'll run without me coming outside doing it. So I go inside, and I got 24 volts, so I just had this little wire, and I go click, click, click. And he said, well, that's good, man, that's a good idea. Until he said, I invented in the garage this temperature device that has a lever on it that senses temperature and causes a movement on a rocker arm on those type of thermostats, not the digital. And when it rocks, the switch opens, and when it rocks the other way, the switch closes, and then I can write some numbers to represent the temperature, and then the linkage connects again at the bottom, and I can actually take this switch and set it at the temperature, and the arm will rock and when it gets to that temperature, it'll open. Now we don't have to touch any wires. That's basically what controls do. It gives us a hands-off operation of a piece of equipment based on most of the time, 98% of the time, 3 ways. Pressure, temperature, and a sequence of timing. That's how it does it 98% of the time. So switches open and close. They open and close by various ways, mostly pressure, temperature, and a sequence of timing. They can be motion, like this one. They can open and close by moisture, like in your lawn, that you get this free on and off operation when the grass is watered. They're moisture indicators. When it gets so dry and low, it comes on by itself. And then when the moisture is satisfied by the indicator on the ground, it'll open the switch and it goes off. That's how it works. So we can control anything by a device that measures what we want to control. It measures. Sensors measure what we want to control, and then the sensor is designed for the medium that we want to control. If we want to know if that filter is dirty, we make some torpedo tubes, and they go on the other side of the filter and they stick out like this. It has little holes in it and it reads air. So since we have cubic feet per minute, it can read and be bought and calibrated for a certain flow of air. If that filter gets dirty, it could be hooked to a plain analog switch is what? Just a manual switch. If it's not analog, it's digital. And it will shut off if not the right airflow is there. So that is an airflow switch. In some systems, where water is mandatory to be a certain level, we could have a water level switch. In a boiler, if we're feeding a tank and the water is not at a certain level and it drops, it's off. That's a level switch compared to the 98% I gave you. And it will close, and then a feed switch, normally open set of contacts, normally closed, so the normally close open, the normally open close, and pump water to feed the boiler. When the boiler has the right amount of water, the switch will go up and the boiler will start and run. So those are ways that switches can control, but no matter what type the switch is still opening and closing a circuit. That's what I want you to get out of it. It can do it manually, like a toilet float. Does a toilet float open and close the circuit?
Yeah.
Whether it goes up like this or whether it's on that ball. When the ball rises to the top of the calibration, what happens to the water valve? Closes. It's always the same thing. It closes. So that's a water level switch. On real fancy cars, if the tires get low, you get a light on your dash. Mostly all cars now, that's a pressure switch. It even says PSIs, 37, 36, 35, 29. Left rear is losing air. That's a pressure switch, still under our same water. The water in your car radiator get hot because the fan has failed. What happens to the pressure and the heat? It rises, and you see that. You got a needle, you better cut that engine off. You get ready to buy your engine, start walking or something.
That's when you blow your gasket.
So, gaskets is like buying an engine. I can't tell the difference. The price, I can't tell the difference.
Yeah.
That'd be about $4,000, Mr. Ham. You didn't have it. You gonna give me the car? Yeah. Sign it over? Yeah. I'm done. So the point I'm getting to is how switches open and close. And they're utilized all in society, in the medical community, in the refining business, in everything we do. switches have to be on all machinery for them to operate in a controlled way. You know why they call these controls? Because we're controlling off and on. Controlling energized and de-energized. That's all they control. And if you on your microwave, we said it's different ways. We said temperature, pressure, and timing. What does microwave do? Two things, right? Heat
Time.
and timing. And it's manufactured in a way, if you push pizza, it's already determined that should do pizza. But if it's frozen, you better push frozen pizza. If it's fish, you can pick certain items because those are temperature controls and time. Ovens are what? Two things, what are they? Time and temperature. Isn't that how you cook food? You ask the question, what I do? What temperature I make it? Seems like it's always 350. 350 for how long? I don't know. How big is it? It says it's 10 pounds. Put it on 404. That's the temperature. About 45 minutes, and then turn it down to 275 for 2 hours. That's what I do. Whatever they tell me.
You don't forget?
Huh?
You don't forget?
Nah, once I learn, I got that. I can go learn how to do something else. I got that. I cook meat. Ate a fish this big when I got home.
A whole fish?
Yeah. It wanted me. So I ate.
It wanted you?
Yeah. I don't eat whole fish. I have no bones in the head and tail. I don't eat it.
That's right.
You bought it cooked or you made it?
Huh?
You made it or you bought it cooked?
I cooked. I buy it from the farmer's market. And then I just tell them to gut it, head and tail on, skillet and gut it, give it back to me on ice. I take it home, put it on my pellet grill or oven or something. Eat it like that till I get down to the little bones. Instead of being a McDonald's fish sandwich made out of block.
Yeah. Same price, too,
I
probably.
ain't eaten McDonald's probably in 18 years.
What type of fish you say it was?
That was red snapper. I also do. I use red snapper, wild caught. Everything got to be wild caught. We get ready to take a break. That's why I'm talking about this. Wild caught.
Can we do coil stuff?
Sound. Can you do it?
Coils, what they do, like the definition of it. Cause I have to go on break, like, and I don't need to program to things, so
I
this.
gotta name my last fish Brain.
Oh, thanks.
Emperor Brand.
Okay. So for Miss Lady, coils. What do we know about coils that's really a must know? First thing about coils is we must know is what? But how does it create magnetism? It's the characteristic.
Positive and negative charge.
That happens, but what is the characteristic of a coil?
Winding.
The coil, the windings, the coil. How thick is the coil? But the coil itself is what helps when applied voltage go to it. Magnify. So the coil works hand in hand with resistance. With resistance. We can read resistance by what measure?
Oh.
And we find it on our multimeter, and what does it look like on the one you have? How do you know you're on there?
It looks
Like a Omega.
like a horseshoe upside
Yeah.
down.
Omega.
You said mega. What'd you say?
Omega.
Omega sign.
Yeah.
Cause I'm like, are y'all so young? You don't know what a horseshoe looks like?
Yeah, horseshoe.
It looks like one of those things. I'm like, what?
Horseshoe.
It looks like a horseshoe. That is true though. Ohms, resistance. And resistance can be used for testing a coil for what reason?
To see if it has.
Amps. I mean,
You just copied that.
It broke.
No,
You shouldn't have. I'm talking about a naked coil.
you say, but it
What Go ahead.
resistance, right?
Resistance and,
Well, for a coil to go, it has to have a magnitude, and that has to be energized. by
but what if it's
something.
not? Oh, you messed up there. I'm
Okay.
glad you said that though,
Yeah.
cause I didn't express
Explain
that.
it.
If we're testing resistance, power must be off. Must be off. You cannot test resistance with an energized circuit. You're either testing voltage or you're testing current or amps if the circuit is energized.
So when
And-
we're testing the coil, we're gonna be testing it.
I said, why are we testing it? How do we test it and what are we testing it for? I'm gonna go back here with Mr. Pilson, man, he's been writing a long time. How do we test the coil?
You wanna test for continuity.
How do we test the coil? But you all right?
Ohms.
I'm just doing it because I'm making everybody talk in this class. It's just me. How would I know if it was good or if it had failed? How would I test it? Okay, so if I'm ohming it, which is correct, what would I see if the resistance coil is good? What would I see on my meter?
But how do the coil
Huh?
energize?
Not if it's good, you wouldn't see OL, because it means open line. What would I see?
If it's good, you will see some level of resistance.
Okay, that is good, don't you forget that. If, when we're testing a coil, why do we test the coil? Because we wanna know, is the problem the coil or is the problem something else? So we take our ohm meter out, we go from end to end with our coil to our meter on ohms. And what should we read here? If the coil looks like that, there's nothing wrong with it. See, you gotta get that right.
Zero.
Voltage is off, it should be,
Listen to me. Listen to me. You can only check ohms when power is what?
Off.
It has to be off. It has to be off. Okay, hold up. And that's in that book, and I'm gonna show you what page. It does the greatest job on that, on what it looks like on ohms. That book is the bomb on that. If it's OL, bam! That's what it looks like. Because OL stands for what?
Open lead.
Open lead. Open lead. That's what OL stands for. So since our coil did not have an open lead and it looked like that, here's what you would see. Each coil, as we said, could be made of different diameters and thicknesses that when applying the two probes of an ohm meter on it, power off, you're gonna get a variable resistance based on the size of the diameter and length of the resistance. But you should see some kind of resistance. Some kind on certain, on certain components, you might see 7, 5, 13. And when you read the literature, it says 7 and 5 is good, acceptable, 13, change the sensor. And they'll tell you what it looks like. I'll show you something else when we do this. Might do it today. When you have a sensor and you drop it in ice water, before you drop it in, test the ohms. Drop it in the ice water and see what the temperature meter does as far as ohms.
slows down.
Keep lying, Yanni. Okay. So coils also have to have a source because coils are incorporated with always another component. So it could be one of the working parts to another component. like a gas valve, like a relay, like a contactor. The coil is there to open and close, but it's part of another component that actually is a switch. Coils are part of a switch. Coils are part of a switch in this case.
Okay.
It's part of a switch in relays and contactors.
And transfer.
It opens and closes. It creates the magnetism that causes the switch linkage to open and close. But it's not the switch, it's the power source for the switch, because you can have failure in the switch mechanically and failure in the switch electrically. You don't believe that? You believe it?
Say that again.
You can have a mechanical failure in a switch, like a contactor, or you can have an electrical failure, which would be in the coil of the contactor as far as talking about coils. That's an open lead, so when we test it, it's gonna say OL, and we know, hey, toss it, get another one. If it occurs in a gas valve, toss it, get another one.
So
If it occurs, yes.
every time, sorry, I didn't want to interrupt you. Every time that I'm gonna check my coils though, that I'm gonna de-energize,
Oh yeah,
okay.
anytime you
And
check
coils is you always
resistance,
check if- I'm trying to get an understanding. Coils is when you always check for resistance.
if you, listen, cause I think you kinda got it.
Backwards.
No, I think I need to say more. Okay, so she says, anytime I check my coil, I need to check it with resistance. Not true. If you wanna check the coil itself to see if it has failed, you could use it. You could use the wires of 24 volts still connected to the coil, switch the voltage, put voltage on one side and the other side, then you should see what if voltage is there. 24. If I don't have 24 volts, I'm going to, and you can take a break. Series circuit. What do we say a series circuit is for? Operation and, you said it, what? Operation and safety, both of them. We can operate a system in series because if everything's closed, it operates. If something opens, for a safety reason, it could be a safety reason. You can also use them for operation on some type of machines. So, if the coil was ending up through high pressure, low pressure, pan switch, drain pan switch, and it ended up on compressor contactor, and it started off at the stacked, with this being R, this being the contactor, and we already know we had a what? We had a transformer, and we had a R, and we had a C on the contactor, and we always take that one all the way down to one side is R, one side is C, to the contactor, so it closes. So if anything opens in the series circuit, what happens to the contactor? It opens, it opens. If this is safety, it opens. Take a break.
What was that last time? If anything opens in a series.
You wanna ask me
If
my
anything opens in a series circuit, here's what it looks like when it opens.
It's all right.
Do I have 24 volts to the contact? No.
No.
So if this opens, do I have 24 volts? If this opens, do I have 24 volts? That shows that the series circuit in residential is used for, many times as a safety circuit to shut machines down if they malfunction. That's what it's for. Does that make sense?
Yep,
Okay.
sacrifice.
Any other questions for your break? What we like about control boards is we can control multiple inputs. Whereas on what we call analog, we can have a thermostat, a transformer, and a motor. when we switch the thermostat, closes, R, and then common is to the other side. This closes, L1 and neutral goes, closes the switch, comes out T1 and goes to a motor and it runs. That's kind of like a single control, right? And I gotta do this every time I wanna control something else. But in control boards, I don't know if you know this, let me get one you can tell better, maybe. On a control board, you see the front, right? Do you ever notice what's on the back of it, have you? Y'all take this one, y'all take this one. Look at the back of it, and you will see some flat shapes, sometimes silver, they make them different. Those are the wire connections in digital circuit. Those are the paths that electric flows in that circuit. It is a small footprint because digital circuits don't take up a lot of room. They don't use and consume a lot of energy. And the beauty of it is that solid state digital controls can be programmed through a circuit programming right here. That's the program. In other words, all boards have a program. The ones in our industry are called hard program, pre-program, meaning you can't change what the operation of the machine is. It's already done. So for safety and any other mishaps that could occur won't take place. The program makes it easy because the program gives us a sequence of operation. What is a sequence of operation?
The order in which things work.
Sequence is what?
And the order in which things operate.
The order in which components operate. The order means what time it occurs, if it's any timing circuits, is it any other barriers, is it safeties? What else is in this circuit? What is the first? So guess what that leads us to? On control boards, buddy, you can't troubleshoot none of this. All you can troubleshoot is two things: inputs and outputs. Inputs can be measured. In the case that we mean temperature, pressure, light sensitivity, moisture, those are measurements. Those are inputs. Then I like to say it's three pieces of information that happens. Inputs, which are components, interpretation through programming, and output that is determined after the program sequences or what's next based on what circuits are closed and open. It's the same thing. If we had this card on a machine, it might be big as that board, right? So now it's this big. And it can happen in a small footprint in a small place. You can take boards as they get more sophisticated. You can make them Bluetooth. You can make them wireless. You could make them communicate and synchronize with laptops. They can synchronize with phone devices and pads in order to operate equipment at a distance. Only possible with digital circuits, what we call control boards. So a control board is really what it says, that's what it is. I'm getting like my mother now. You need to move that off the center of the floor. I can't help it, man. I'm just kidding. So a control board, thank you. A control board controls something. Don't try to complicate it. That's why it's simple. It's a control board. In this case, it depends on the piece of equipment. I'm going to simplify it before we start increasing it over the next couple of classes. If we are dealing with a motor or trying to operate a motor, what are we going to control it with? What are some controls? What do we need to make a motor operate?
Capacity.
Switch,
Maybe. We would like a switch.
power,
We would like power or electrical, and that is neutrals. And then you will have M1, M2. You have a 24-volt tag over here. So operating a motor could simply be taking a plug, putting it to the power leg and sticking it in the wall. I'm operating. That's not controlling it though, that's operating. So if we want to control it, what are the ways we can control?
Hey.
Pressure
Pressure, status, temperature, what else?
and time.
And timing. There are many timing circuits that occur on these boards as well, as you'll find out, as well as in wall stats. Because how can a wall stat be a control?
Manually.
It could be manually, because you said to me, it's two things you can do on this board is what?
Input and output.
So guess what a digital stat you have to do? Input a temperature, and the output is the results of what you set it for. It's automatic control based on temperature. But there's also timing in that stat, because many stats are timed out. They're not initially energized, and especially in cooling, some have 2, 3, 7-minute delays, and then it will energize. That's a timing circuit. Anytime we put a timing circuit, we're looking for protection of a machine, whether it overheats, underheats, or overamps. We need protection on that circuit to keep someone from going on the old thermostat. Click, click, do, click, click, do, click, click, do. Every time you cycle and energize that equipment, close that contactor real fast, you're causing that ramp voltage on that compressor. It can damage it, could burn the terminals off of one of the terminals on the compressor. It could spike the contactor and put stalactites and stalagmites on it because it's arcing. It's arcing. And every time it closes, it's gonna arc. So controls are for safety and operation. They come in many different formats to control different items, and guess what? I can have more than one control on the same system. We have a thermostat controlling total system operation. But the other thing about these stats, and I don't like to call them thermostats, I like to call them wall controllers now, because you can set time of day, time of week, off and on operation, for how long, preheat, pre-cool, termination, all of that on a wall controller. There are other items you can do as well, but we're staying with HVAC. So it is a controller. Delays of operation. You set it like I'll be on by 11 p.m. I'm gonna turn my furnace on from 60 to 72 when I leave. And when I get home, it should be 72 degrees. People do that. That's timing. Whether it's a month, in other systems, we use timing circuits, and it's on the board, control board, to tell us when the annuals for filter changes, coil cleaners are due. And guess what they'll do on a fancy system? Not fancy, it's more expensive. They'll send you an email. Time to change filter. No circulation in the fan. Send you an email. We use those type of systems. But the board, the very careful thing I want us to know is only use the terminals that are identified. And we've done this a couple times. Can't do it too much. R, C, W, Y, and G. You also have a humidifier connector. You have a L1, L2, hot surface igniter, transformer connector, all neutrals plug in here, and this would be the automatic igniter systems and 24 volts plugging in on that block going back to the motor itself with all those wires. So that's a plug-in. And that's all that we can really do here. You have this one even tells us that you have a off delay. Off delay is referring to, you can pull this little tiny little part and stick it here. It has 180, 160, 140, and 80. That's referring to the time off delay of the fan. So what that means is, after you reach set point of heating, all controlled by this board, by sensors and components. You don't have to be concerned about all of that. We just want to be concerned about what do we connect to, what's the voltages, fan relay, capacitors, you don't even have to know that. And that is our diagnostics LED that gives us flashing lights and gives us a place to start when troubleshooting. Pretty accurate, 98% of the time. Pretty accurate, except for flow switch circuit. It's not accurate on that, but it is accurate on everything else pretty much. Get familiar with these boards, look at them. You can come to class and individually just pick them up and look. These are resistors. Remember we said the 20 amp resistor? Part of this definition of being on the board in your book, how do we know the ohm value of this resistor?
Color code.
So gold, red, black, and brown, gold, brown, gray, and brown, gray, brown, green, and brown, all represent a different resistance value. That's how you know what it is. Whether it's 100 or 200 or 40 or 60 or 16, those rings. You ever notice why they had rings on them? Was it just to make them pretty or something? You know, it's because it tells the value of that particular resistance of an ohm. You have capacitors on here. You have diodes and diodes and triacs. Triacs are, and grid circuits are switches that are digitally switches. They don't have physical movement. You know electronic don't have no physical movement. It can be a switch. I like to compare it sometimes to a garage opener. And you walk through that beam, right? And if you walk through the beam, what? Go back up. It's for what?
Safety.
Safety. And it is a, what kind of switch? Huh? It's an automatic switch, but how does it work?
Motion.
Motion. Remember we said 98% of the time is temperature, pressure, sequence, and timing, but motion also plays a part. And that's a safety because they figure you move unless you get smart, go like this, which I do sometimes, go outside because I'm lazy, and it's gonna close anyway. So you better stop running at your old boy. So questions about a digital board. And then we'll talk about the sequencing and what it means. The sequencing of operation, asked about it. They're on everything. They're on a heat pump, that's different. They're on the air conditioner, these furnace boards are on everything. It is a connecting hub. It's a hub where everything connects. Low voltage, low voltage, line voltage, the operation based on programming. It's a load center for every operation and switch point that's powered up through this board as far as the open and close. This is a one place switchboard operation. There are other switches throughout our community of equipment external to the board. But that external has to come back to here. It comes back to our, which
But
came
if one component breaks on here, the whole motherboard fails, correct?
If the motherboard fails,
This one little piece isn't working, then the whole motherboard is failed. Like you can't
well,
fix it, right?
if fail means it won't operate as designed, that's true. But often one component can fail depending on it, and the board is still like the fan motor are running, but it won't sequence. Something else won't happen because the main components on here, that's neutral, that's line. Some of these, like fan relay, that's history. You can't change this. That's why it's on this table. You can't change them. So one component failing on here means this component goes. It's gone. You can't fix it or shouldn't attempt to fix it. This is the component made of hundreds of other components, but each component must be operational in order for this to be a part that benefits the operation. This is an operator. I'm calling it an operator because that's what we call them in commercial. It's an operator. The thermostat is an initiator because it initiates the call, heat or cool. So the stat is the first initiating sequence to the switch. Book doesn't say it, I say it, because that's what it is. They end up saying, okay, so the sequence that is being discussed in the book, they're more concerned about, you should know that this board controls the sequence of operation of a furnace. That's the case.
Mr. Harris, the same way you can jump out the thermostat, you can jump that out too or no?
Can you jump this board out like you can jump out a thermostat?
Yes.
Absolutely. Where does the thermostat get its power from? And you're right, because sometimes I sit on a bucket and I go from R to G, what should happen? And I do it that way because I sit on that bucket and I want to see if that motor comes on. And I go from R and Y, and what should happen? What should you hear?
The condenser fan.
Well, it could be the fan, depending on how good your head is, you might hear the condenser fan. The one thing I'll notice is, from doing this, is I'll see the liquid line and the refrigerant lines jump. Because I'm right there. You turn it on, it goes, and you can hear that refrigerant. I say, oh, it's pushing the refrigerant. The compressor's running, but I don't know if the condenser fan is running yet. But the compressor is running. And so you will know that. Yes, you can jump this switch out and be a thermostat. You become the thermostat right here. And you know what else we use that for? If I can jump it out here and every part of the system runs, if I can jump out Y, would I jump out for straight cooling?
Y, R, and G.
Okay, so what do you expect to be on if I jump out Y, R, and G? What components should be initiated? Yeah, that's true. The fan and the condenser. And when we say condenser, we're talking about the whole outside unit, but in reality, we know the condenser is made of several components in itself. Compressor, fan,
Thermostat.
well, not outside.
Oh,
the
shit.
low pressure, high pressure switches, contactor, capacitors. It's made out of the coils, of course, but several other components, and we call all the components that are there, dryer, if it's the air filter dryer, we call all of those components the condenser. But the condenser is the part of the system that does what? Doesn't cool, it rejects heat. It's known as a rejector. The evaporator is a absorber. So I don't want to get into the physical aspects of refrigeration. I want to stay here because 80% of all the problems is electrical. Because some switch is closed when it should be open. Some switch is open when it should be closed. That's our business. Go ahead, get you some tools and go to work. Some switches open, it should be closed. But what we're learning is, how do we determine where those switches are? Ask questions.
Oh, what was that right there after the low pressure switch? What is that?
That would be a pan switch. Whenever we mount a furnace in the attic, over a ceiling, drywall, you must sit that furnace in a overflow pan, kind of like that you put a washing machine in. You ever seen those? You put a washing machine upstairs in the house, you'll see that big plastic pan that you put the washing machine in, and it has a 3/4 inch PVC pipe connected to a spout that goes outside, because if that washing machine breaks a leak in a seal, it'll flood you upstairs. You're gonna have carpet, wood floors, and that ceiling. And that's gonna be ugly. That might be 40 grand. So you put that pan there. So we do the same thing. Ours are made out of metal. We put a overflow pan, a secondary drain pan, put the furnace inside of it, and then we have an overflow switch that's in the pan that works like a toilet float. And as it goes up, it will shut off, open a little micro switch, because the switch is like this, and the lever is sitting on it. So as the water raises, goes up, the switch opens. And that switch is in what circuit? Yeah, but what's the power? 24 volts. So if I lose 24 volts, will I make any water in the air conditioning anymore? Because the compressor's not running. So the drain could be full, it could be a low charge, it could be a number of things. Drain pan could be cracked, it could be a separated PVC drain pipe that sometimes people don't glue, and it could have came loose and it's just dripping down. So that's what the important factor of series circuit on residential equipment, having controls in the circuit to energize, de-energize, off and on operation for the equipment to operate safely. That's all it's for. Either operate as required by set point or operation according to temperatures and pressures. Questions? Setting you up for lab. Questions? You just have parallel. You're either gonna be wiring most of the time parallel or series, and sometimes parallel and series. And parallel and series is L1 and L2. L1 and L2 on a ladder diagram can go to a load on many lines as you want it to. It's going to a load. But the load has to be controlled. So that's why most loads are carried through some type of relay, and they have to be controlled to on and off of the load. So the series is this, but parallel could be straight down. Series parallel could be that this is only one line that is in parallel to the other lines, but that one is in series with the safeties, and it will not operate. So if you did it in a line drawing, you would have to make sure your bottom half was low voltage, controlling the top part through relays and contactors, which is the top part of the drawing. You ain't ready for that yet. You gotta get this first, you ain't ready for it. Cause that one is really a buster to kind of get in your head. Until you really get it in your head. The bottom part of the drawing controls the top. Why? Because the bottom part of the drawing represents low voltage. And low voltage controls what? Line voltage. So they just draw it that way. You even know what it does, but when you see it in a drawing, it looks like a foreign language from a foreign world out of space. Nobody on Earth speaks that language. So you're learning the language nobody on Earth speaks.
So the line voltage is on the top of the transformer.
Well,
and the low voltage is at the bottom of the transformer.
you could say it that way, but line voltage on a transformer is where it says line voltage, and it'll tell you the color. Low voltage is only gonna be 2 wires. And that's not to say that you could buy a a transformer that has 2 wires. It'll tell you, they don't try to make it difficult. output for 24 volts is what? They don't try to make this hard for us. Read it. That's why I said we started with nameplate that. What is output?
24.
What's the color of it?
Blue and yellow.
There you go. You don't have to guess. Was that hard? That's why you read nameplate data. It said blue and yellow is 24 volts. I know what it is. Then it tells you what the other voltage is. It says, what is the common wire to the rest of them? What color is the common wire? It says,
Common?
yeah, it says it. You ain't gotta guess it.
Black.
Black is common to the speed that you want. So black is gonna be common if I use blue, not blue, they don't have it. What is red and black? What's voltage?
Red is 208 voltage.
And black and orange is what voltage?
240.
You see how easy that is? So don't go in the lab and wire that stuff up wrong. Because it's already telling you on a 115. 115 is what? Black and white on that one?
It doesn't have, it has 120.
120, that's it. So black is common, white is 120.
It doesn't speak about this green one on the side over here.
That's a good question. The green wire, I'm glad you said that. The green wire on the side is a ground.
Oh, that's the ground.
All equipment energized must have a ground, or you will be the ground. The panel box outside with the meter has a ground. And some of them have a ground rod 15 feet in the ground, so it goes earth ground. The panel box inside has a ground. The disconnect outside has a ground. All those grounds, if wired correctly, will go back to earth ground, and no one will be getting electrocuted or shocked. All your motors and equipment on the machine have to be grounded. I see many of them out there just flapping. You'll say they just flapping. I said, dang, they put a new motor on and then he ground it? All you have to do is take it and drop a screw, drill it into the metal, so it'll be equipment ground.
Before energizing.
Of course. So yes, ask another question. That was a good question.
Well, so if we go for a troubleshoot machine, you said that ground, before we touch anything, you know, and become, you know, fry fish because it's not grounded.
It should be grounded.
To double check where the ground is, that's normally.
Well, one thing I do,
In the cross
I'll
space.
open up the disconnect, and it should be grounded right there in the disconnect. And the disconnect is grounded going back to the breaker. And then the machine is disconnected, grounded to the case ground, we call it case ground to the case. Pop a screw in any metal surface is grounded if the ground continues back. So, I'm always conscious of anything that's old, that's been worked on a lot, that looks kind of funky and raggedy, got different motors on it, people been trying to keep it going. I'll look for that, because a lot of times they do not ground that. And sometimes the green wire is green and yellow, stripes. And many times and oftentimes it's not grounded.
Just the outside unit, is it grounded to the ground?
It could be grounded there, but it's also ground all the way back to the breaker, because we run 2 hots in a ground. That's what it's called, to that unit. 2 hots in a ground. L1, L2, that's the hots. The ground is a bare ground. No wire on it, it's just a thick copper bare wrapped around a screw, zoop, to the disconnect metal box. And that ground goes all the way back to the breaker. If you took the cover off, you will see the ground right there. So it's earth ground down into the earth. And the grounds are continue to be grounded. That's something. Because I'm not gonna get into no sequence of operation. I don't think y'all ready for that yet. I ain't ready for that yet,
The sequence cover? Yeah, we
Can you write it down when you got to write it down?
Sequence of operation
What's that?
of, oh, she the one that asked.
Thermostat, Inducer blower motor, pressure switch. What's next, y'all?
I'm gonna erase this.
Thermostat, the
I'm
thermostat,
gonna erase this.
inducer motors, switch, we got igniter,
Oh, yeah, surface, high surface igniter,
igniter,
gas, the gas
gas
valve.
valve in the door. Gas valve, flame
Y'all naming some components, that's not bad.
Flame
When
sensor.
the fan comes on.
Okay. Sequence of operation for a, what?
Can we do both of them?
Both what?
Electric.
Furnishing, I guess. Furnace first.
Okay.
Gas,
Gas? Gas?
gas, yeah, gas.
80 or 90? I'll do 80.
What is this, 80 or 90 what?
80% efficiency and a 90% efficiency. There are a couple of different components that separate those, even though they're both high efficiency furnace. 80% means this. 80% of all the heat that's created by that furnace goes in the house. 20% goes to the furnace.
Oh, okay.
80 cent that you pay goes to the power company. 20 cent is wasted. 90 says we can do better. We put 90% in your house, only 10% goes in the air. A 90 plus says we put 96 in your house and 4% at a cost of purchase of the equipment for thousands of dollars or more. What is the payback in 10 years? Okay, so sequence of operation. Sequence of operation for
Do you know why, Mr. Lawson put the March 1st on his thing?
yes, because he has a mandatory 1 week training for his company.
Okay, so that's why first, okay.
Yes.
All right.
Sequence of operation for a 80% gas, natural gas furnace. Kids don't like cursive anymore, do they?
No.
They don't know what that is,
I
do
heard they took that out, yeah.
they? They took it out some time ago. I taught all the little babies in the family how to write cursive. They like it. It's so fast. It's so fast, you know. So, the first thing that we need to know before we start talking about internal switches and controls, I always want you to go all the way back from the start of where voltage comes from, because that could be part of the problem for the service car. So voltage goes back initially to what?
The breaker box.
Breaker box. Ooh, look at that man. Breaker box. Then what?
That
Disconnect.
disconnect box,
Disconnect.
service box.
2 places it can go. We have a breaker box, and the breaker handles each load. Ms. Harrison? What? Why? So what you want me to do? You got any power on the computer? Well, it's not enough power if that happens. It's not enough power to to power it up. Oh. Well, how you gonna straighten it out now then? Does the power go from the inside service disconnect?
From the service disconnect, it goes to the furnace door.
Thermostat.
The
He
furnace,
said
the
furnace door.
Oh, that's what he said.
Yeah,
Hmm?
the switch.
How'd you know that? You said furnace door switch?
Yes, Yes.
Why?
The one, when you open the furnace, that switch,
What do you want to happen?
that's like a cutoff.
Why?
For safety.
For safety. For safety. So from the service disconnect on the inside, we go to the, most people don't get this right. You got it right. Furnace door switch. Take the bottom door off where the air handler is. It's a little button. You be on the left, the right, the center, different types of buttons. It opens. When the switch opens, we no longer have 120 going where? Where does it go from there? From the door switch.
From the door, it goes to the.
What did you say?
I caught a brain freeze, I hate it.
That's all right. You get it next time. Where does it go? Goes to the circuit board. We just said this is the controller. This the boss.
From the
This
door,
the boss.
From the door to the second,
From the door to the control board.
what of the transformer?
Transformer goes to the control board too. I said the control board is the boss. Anything that operates because of this control board. It's powered up. But we just powered it up through that door switch. You were correct about that. And so from the door switch on the 120, neutral goes here. And then of course, we have line voltage on there. So that gives us 120 volts applied to this board.
You can take that.
And what do we do with the 120 volts? Any component that needs 124 volts will automatically receive it through the sequence, through this circuitry. See all the circuitry? It's like running wires. Circuitry on a board that's flat like that is a wire. And it's sticky because it has a material that insulates and protects and encapsulates these inserted connections. So we say, okay, everything is here at this point, so neutrals are here, and we have to have a source for our transformers. Right here it says 5A, what does that mean? 5 amp what? Fuse! 5 amp fuse plugs in here. I take it out on exams in the lab sometimes. Students sit there staring for minutes. 5 amp fuse goes here. 5 amp fuse plugs in here. Just like a car fuse, right? Like a car fuse plugs right there. If that fuse is gone, nothing works. Nothing. That's a 5 amp fuse. Plugs in right there. All boards have it. It's probably pulled out because they stole it. 5 amp fuse plugs right there. Okay. What color is a 5 amp fuse?
Right.
Green. Not it.
I just guess.
Red. Nope, it's 10. Blue.
It's blue.
What color's a 3 amp? You're right. It's yellow.
But this ain't got one.
You know something. Okay, so we're neutral here. We have an igniter that plugs in here. It's all plug and play. Plug. We have our harness here for automated, right here for automatic igniter. Plugs there, bing. The rest of the harness that feeds the other components plug in here. Bam. Then all we have to do is put our wire for cooling. If it's for heat, and it's green, it goes here. If it's red, black for cooling, it goes here. And you know why? Cause it told us that's where it goes. It says heat and cooling. I told you don't have to guess none of this stuff. It says that one's for heat, that one's for cooling. It tells you where it goes.
This one don't have a 5 amp.
That one might not have one, yeah, it's right here. F1 fuse. They have to. They ain't gonna let that $700 board go for no doggone 10-cent fuse. Okay.
Locate the 5 amp fuse.
Yes.
Some of those boards have a Y and a Y1.
Locate the 5 amp fuse.
Y1 and Y2
You know where is it?
could be for a two-stage compressor. I have two compressors.
That's one.
One is Y1, one is Y2. It's another way of controlling load. If I have a 10-ton compressor and a day like this, why would I pay all that money to run 10 tons if 5 tons could do it? So they run the 5.
They run off of,
Relays.
no, I'm talking about, it would kick in when, I guess the temperature's a certain.
If they work different ways, if the system, 5 tons cannot keep up with the load because it's getting hotter outside, then the second compressor will kick in, because that's the main load of the building, or calculated load of the building by standards by either Manual J or Manual N, was determined that is the load of the building in BTUs. So that's the maximum. You can split the maximum. You can have 2 coils where each compressor is on an individual circuit, which is the way I like them.
2 separate thermostats?
One thermostat,
Mhm.
Y1 and Y2. Control
Okay,
each
it's
circuit,
on both. That's okay.
Y1 and Y2.
And it can be done on time or pressure, either one, or both.
It can be done on temperature. It can be done on pressure if that's what you want to control it by, but temperature control it. Because pressure is temperature and temperature is pressure. Of course, the low voltage goes here. Name's low voltage. From here, it goes to the thermostat. So from the sequences from the furnace to the door to the what? Control circuit board. And the control circuit board is the system. We're gonna say brain. I don't like to say master. The system brain, the motherboard of all, but the system brain, all operations. So now we can talk about something else on this board. Since we talked about the physical connections on the board and how this starts off, if this doesn't control or occur, sequence can occur, because all of those connections have energized this board: gas valve, inducer fan motor, igniter, limit controls. Everything from the series circuit of flow controls, low pressure, high pressure, come back here. They come back here. Sequence of operation is one of those things you probably need to know over time. Some of the other stuff you really don't have to, but you do need to know sequence of operation. Chapter 3, 5, 10, 30, 31, and 43. You need to know that. 3, 5, 10, 30, 31, and 43. There's other chapters, but you need to know those, yes. Oh, she was first.
It's in the big book, or?
It's in the big one.
Okay.
Chapter 10 to show you, chapter 10 in the big book. I mean, all of that's in the big book.
My question, can I ask my question?
Yeah, you can ask a question.
My question is, so the other day you told us that you need the flame before you do the gas. So why in the sequence of operation is it that the gas valve opens first?
Where'd you get it from?
What?
That sequence.
Where did I get it from? I think this is a collective effort.
Sounds YouTube-ish to me.
No, okay, so, I want, after the surface igniter, the gas valve opens and then the flame lights, right? Or,
It should be, I have seen some systems work like that. It is recommended and mostly practiced that fire before fuel. Because I want it to light off. I want the fire to be there, so when the gas hits the fire, it takes off and becomes a burner. I don't want gas to open, discover a flame, cause that could roll back. That could be flame rollout. I don't think that's a good practice. However, if the flame sensor does not sense fire in a portion of a second, it instantly has 100% shut off on the gas valve, instantly. So it's not waiting around like, whoa, we need to close it. If the gas comes on, it goes, and there's no fire, like that, it shuts down the gas valve. But that's still gas, which before it starts again, that's why the inducer fan motor runs, so it can remove any residual gas that was left up in the heat exchanger during a misfire. I say eliminate misfires and have fire before gas. It just makes more safety sense to me.
but these are already out here, so some operate in
I've
reverse to where
seen some
the
like
light
that.
and flame come first.
It's a
then-
very quick, it's off. It's looking for a flame instantaneously. So in order to light like that, it already has to have initiated the glow. It had to initiate it, because it takes like about 5 seconds for a surface igniter flat to even glow red enough or hot enough. If it was a spark, it might do it. Because if you had a spark that was gas come on, it was going tick, 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 it might light quick. But a igniter, it has to glow. It takes a few seconds to reach maximum heat in order to light a burner. You know, I don't agree with everything, but they can say what they want to say. They must not service this equipment. I don't know who that is, but just in case it's the owner, this is Harrison, may I help you? Cause they have a lot of cell phones and I don't know what they are. I called you 3 times, Mr. Harrison. I was teaching your students, sir. Okay, so the control circuit board is the system brain, and now we can get into the operation of what it is controlling. It is controlling both inside and outside mechanical systems, but right now we're sticking with gas, 80%. So now we have the board connected. All our power is there. We even have low voltage connected to the low voltage terminal, ran it to the thermostat, and we're ready to rip. What, yes?
So I want to add, so when y'all say jump, when, I guess troubleshooting thermostat, when y'all say you jump, so are you physically going to the thermostat, or are you trying to?
You can physically jump a thermostat, or you can jump at the control board, R and G. Or you can go to the thermostat. What are you jumping it for?
So if I was for heat.
Well, does it have low voltage power?
Sure.
How you know? How can you find out real fast? Real fast.
Turn the fan on.
How do you turn the fan on? There you go. That's our first check. We put the fan on the thermostat to on. If the fan comes on, we know 2 things. What do we know?
Fan work.
24
But what do we know as far as voltage?
That's 24 volts.
You have 24 and you got 120. Because the 24 closed the relay and the 120 close and the fan start to initiate. We know that. So now we have to figure out, so why is it not igniting? Or why is gas not on? And we can take it further. We know that the door switch is connected because the fan had power because the button was closed in and it went to the car. We know that. So I always make a physical look. I don't just jump. So I'm gonna go to the furnace and I'm gonna see if the gas is turned on. What if somebody just moved in that house? And they moved in the summer. And you coming in the winter and well, no, we had no problem all summer. But this is the first start. They might have had the gas turned on for 4 months because they got a gas stove and a gas water heater, but they ain't worried about that furnace. You got to think. If somebody left that house, what did they do with the gas when they left? They turned it off. And I turn it off also by the gas valve. I put it off. So there's no accidents for any reason. You're gonna have to have a tech come to turn it on. So I'll put the gas valve on. I turn the gas main little inline valve on, and then I see if we get gas flow. I want the thermostat to operate before anything else. I want the thermostat to operate because that is our controller.
Yeah.
I don't want to be the controller. That's why we paid $4,000 for all that stuff. Control your own self, motherboard. Go cook that dinner. Oh, I can't talk to mama like that. But go make that furnace run. Make that furnace run. That's what we're there for. See who didn't. We're trying to see who didn't show up for work. See, I try to make servicing fun. I don't try to make it look like, well, pi times the radius square should give me. I just try to say, I actually did. Who didn't come to work today? One of y'all didn't come to work. That's why the furnace is not running or the air conditioning. But I'm gonna find out who didn't come to work today. And you know who I call the workers? The components. Somebody didn't come to work. Or even worse than that is what? Somebody came to work and they hide and they ain't working. But they're here. They're here, but they're not working. They're not working. And that's why I make service calls fun for me. And I say, who doesn't come to work? Well, he come to work and always go to sleep. That's why the condenser motor not and the compressor not working. He always comes to work. That old man been working here 27 years. He always come to work. I think he might have got sick today because he ain't working. You know, I actually do that running service calls. And it makes it not a hassle, it makes it fun for me. And after you do it a little bit, you're gonna know what's wrong like that. You think you don't right now. You do this stuff for a while, you'll figure it out before you eat it. Maybe 60% of your service calls gonna be the same thing. Then every now and then, about 10% you run into something new and you gotta scratch your head a little bit because you haven't had this one before. That's why we keep going over these components. So the control board is in. You said the next thing, what's the first thing? Y'all said it earlier. Now what's the first thing to happen after you set the thermostat to the temperature you want for heating? What is the expectation? This is servicing. If it's 60 in the house, I set it for 70. What is my expectation? That it comes on. That's the first step of servicing. I turn you on. Did you come on? If you didn't come on now, I have several other things from door switch to breaker to thermostat, but we know we have 24 volts because you stroke it to fan and it came on, so we know we good there. I don't have to go to the breaker and check that, but I can go to the main air handler and say what's going on. And so I'm going to look at the board at the LED light, and that light flashes and on the chart next to the furnace, what does that flashing light mean?
It gives you a number.
And it gives you a number. What does the number mean?
Doesn't it have like a?
That's the problem.
For the number. So if it was like, yes, it's like on the panel of the door, it shows the
Yes.
numbers for the blinks, amount of blinks, to
And it gives you
indicate which is the problem.
what could be the problem. And I check that next. And if it hadn't been on, I'm gonna turn it on the first time, right? And see if it'll give me one. Cause when you first turn on the furnace and somebody just moved in, cause it hadn't been gas on, cause they moved in August, it could have air in the gas line. And a signal on the LED could say no gas. It doesn't have gas because it's air in the gas line. You might have to purge it several times before that air bubble, maybe outside on ground level, clears up in the attic and it lights. And sometimes you can smell it a little bit, but you really don't smell gas. What do you smell? Because gas has no smell. Gas doesn't have it. It's the additive, the chemical. You smell the additive. If it wasn't for that additive, you would die because gas has no smell. So that means somebody was smart again. Did you do that in your garage and add that and make that additive so we could smell it and know it was gas?
I hope whoever did, put it in.
I wonder, I always think like this, I wonder what happened to the, before they did that.
Ooh.
There's probably people laid out all over.
Dropping like fire.
It had to be.
For instance, when the light is blinking, so it tells us what?
The LED, the light emitting diode, the flashes, are designed in part of the controls of the board. This is really amazing when you think of it. Because it's kind of like your telephone. I can say, call home, call here, and it does it off of a voice. So if we can voice activate, certainly we can sensor activate in a series. So what did you ask me? The flashes. The flashes represent the problem. And so the flashes, when we talked about the card having different connecting points on for the sensors that sense something, whether you're the flame sensor, the igniter, the inducer fan motor, the low voltage, the line voltage, whatever is plugged in here as a sensor or an output will be connected through linkage of digital circuitry that is programmed to respond to temperature, pressure, whatever it is, and flash. The flash is connected to the cause and the problem. Isn't that amazing?
It's amazing.
On this little thing.
And new school, still flashing? They still flashing?
Yeah.
Like with the Bluetooth thermostats and all that?
This flashes if it's an issue.
I'm talking about the furnace.
Yeah, on the furnace, this a flash.
Okay.
If it even have a light when it's normal, it's a normal operation. If it has another indicator, it might say board has failed. Board has failed. So you get a signal, and this is a must know. Now we're to the point of what's the first thing that happens on the gas heat sequence of operation. Inducer. Oh, shoot. Inducer, fan, motor. So the inducer fan motor starts. What is the purpose of the inducer fan motor again?
Take fumes out.
Take fumes out, make not only that, but the purpose is to make sure the exhaust system is clear. There's no dead birds, a squirrel, anything, rags from last summer's roof, anything. And the inducer motor running itself does not alone help us determine that it's clear. The pressure switch that's connected to the inducer fan motor, as you'll find out in lab, the hose goes here and the other hose goes here. When that fan turns, it creates a flow. That flow goes into this tube, and if it is the correct flow, this one was 0.69 PS. if that flow is what we expect on the back of that switch, this switch will close. If it closes, we initiate the rest of the sequence of operation.
That switch right there, that's a switch, the next, that's a, we on number,
We started with
number
first.
6. That gonna be number 6, that switch right there?
This?
Now the switch you just had in your hand.
No.
No.
That, we're talking about, I went to those 4 that was over here. I didn't go this far because I went to the board, and the board we're gonna list the sequence of operation.
No, I wanted, the next sequence is a switch, but I was just wondering was that the switch?
There's always a switch.
Did you skip one from 4 to 5?
Control,
Control
inducer
board.
fan motor,
Then the switch.
control circuit
Oh, that was
board,
the thermostat first.
thermostat,
After the control circuit board. It send the signal to the thermostat, right?
breaker box. Oh yeah, because we were doing, this could come here, and we'll put stat here as well. Because we were doing line voltage at first. Now, once we started talking about that control board dealing with the sequence of operation, here's where the game change comes, is because we know that the control board, remember we said the control board encompasses all voltages to that machine. And we know that because it has a fan relay. You told me it takes 24 volts to close it, but it gives 120 volts to the fan motor. Does it make sense? 120 volts to the igniter. Some items are higher up in voltage. If it had an air cleaner on it, it'd be 120 volts. If it had a humidifier on it, it would be, depending on the kind it was. So, inducer fan motor starts. That's good. If the inducer fan motor doesn't start, what do I do?
Go check and see if something is blocking,
Check the pressure switch.
No.
blocking the,
Inducer fan motor runs the pressure switch. If the inducer motor does not energize, doesn't come on, blockage is not gonna make that motor not come on. It will make the pressure switch not work.
See if it got 24 volts?
The inducer fan motor doesn't have 24 volts. The inducer fan motor has 120.
Yeah, man.
This is a new thing. The point I'm making is this. If the inducer fan motor does not operate, nothing works. You don't need to troubleshoot nothing below that. Pressure switch, none of that. The problem is inducer fan motor circuit. No fan motor at the inducer, nothing works. That's the first lesson we learned with a sequence of operation. You don't need, let me check this, you don't need to check anything. If anything, I'm gonna check the board where it says inducer fan motor and see if it's 120 volts coming out of it. If it's not, oh well, it'll be on the table in here. It must come on. Does that make sense?
Mm-hmm.
I ain't gonna feed y'all too much more today, cause I can read your faces. You know, I ate more than you can hold.
So it's a
food
pressure.
on the table.
Oh,
Okay, once the inducer fan motor comes on, what happens? Masked man, what happens?
I'm not sure, honestly.
Okay. So if the inducer fan motor comes on, I heard you, pressure switch is next.
Yeah, that's why I asked you a while ago.
But now you don't have to.
Yeah, you were saying, I thought the pressure switch was on the inducer.
it is.
You get what I'm saying? I was asking
You talking about
It
this
is.
question?
when I asked them that, that switch.
Talk to me, don't be talking no third party. You
No,
telling her and then telling me what you trying to say.
Nah, that's what I was asking was that pressure switch next to what you had right
Right here.
Yeah, but I was thinking that It was two switches on the inducer and the phenomenon.
But a 90 has two of these. That's why we're doing the 80. It has two. I don't wanna complicate it. So the pressure switch is a safety to assure that there's nothing in the vent, it's smooth flowing, we're producing enough pressure to make a relay on the board that allows what to heat up?
Igniter.
The igniter. Igniter. Igniter comes on, what happens quickly? Either if it's gas or igniter or igniter or gas, what happens there? Gas valve. After gas valve,
The blower.
burner's light. And then what happens? Something got out of place. Because after the gas comes on, you can put it this way, burner's light, and then we'll just put it here, flame sensor. Because the burners can light, but if the flame sensors doesn't sense flame, the burners are going instantly out. If you can't read my writing, ask me. They've been asking me ever since I.
Can you slide on this?
Oh, yeah, sure.
It's you in the way.
I'll get out the way.
The fourth one. What is that fourth one saying?
Flame sensor.
Flame
So that's
sensor.
flame
Yeah, that
sensor.
license right on.
No,
Once flame sensor
before that one.
says,
Gas
Gas.
furnace.
there's one other thing you have to remember.
Gas valve.
Once
Yeah,
flame
burners,
sensor indicates that we have
Gas
flame,
valve furnace.
what's next before we run real good and operate? Another thing.
Inducer, pressure switch, ignition,
Well, we know
gas
it's open because
valve.
it's flame, and the
Flame
flame
light.
sensor said we know it, but it's something else that happens
Flame.
next. Some people forget it at first. Igniter goes off. It goes off because flame sensor still has flame on it. That's how the system on the board knows that the igniter can de-energize or it would burn out. It's an intermittent pilot. There's a standing pilot on Granny's furnace that stayed on all year long, and sometimes you had to light it. But these are intermittent pilots, which means they only are lit by the igniter or spark on a call for heat. They just come on, that's why they're intermittent. And so, as long as the sensor has flame on it, 3/8 of an inch to 1/2 inch of the tip, it will generate enough heat to transfer that heat to a signal voltage that when it goes to the board, will de-energize the igniter circuit. Now that furnace is gonna run until it reaches set point, that's it. So you do have to, flame sensor, and we will say 6, we
Igniter.
will say, igniter de-energizes. De-energizes. So that is that circuit, and what we do, let me tell you what a sequence of operation allows us to do. The sequence of operation gives us a written form of how the system should operate. And all we have to do, if whatever doesn't occur, we get either the flashing light or we visually know what it is, we test and replace and correct that problem. So it is a great thing that we have digital circuitry that flashes a indicator light that tells us where it is. Most other issues are right on the nose when it flashes. It is just what they say it is. So your biggest job is gonna be changing motors, gas valves, and other components, because it done told you what it is.
Sure is.
That's all you're gonna be doing. And the more you don't have, you'd be surprised, you don't have to do it a whole lot of times to know how to do it. You gonna learn quick. Do it about 5 to 6 times, a certain type of issue problem, you done got it. You got it. Only thing that changes if screws are rusty, you like, oh man, boy, I can't get it out. And then you're gonna start buying different kind of tools to deal with that situation. You can't get your hand way back up in there. And I go buy some extension, small 3/8 sockets so that I can get way back in something, and magnetic head, tools. Cause you can't hold, if you can't get back in there where those sensors are, you're gonna have to remove the gas train. I don't wanna do that. I have a couple of times, I don't wanna do it. Cause I gotta disconnect the gas, shut it off on the side, untwist the pipe, take out the pipe from the gas valve so I can slide out the burners, and then mount that part and put all that back in there.
What that part you did, you actually did it.
This is transformer.
No, remember the one that beginning of the class?
Oh, yeah,
What
yeah.
was that?
What's that look like, the middle of the trumpet right there? Valve.
That's a valve.
It's a,
What is it?
like-
These ears.
Let me see. I'll tell you guys.
You gonna tell us?
That is that's the burner. I mean, the,
Is that the burner? That's what he said.
what is it?
That's all I thought too. And then I thought it was like at least 4 or 5 of them versus 3.
What was that I just had?
That what you just had is a 4-way valve, or otherwise known as a reversing valve for a heat pump.
That's what I meant to say.
Now, how can you say an elephant is a sheep and then say that's what I meant to say? You can't say nothing like that. There's nothing wrong with not knowing. How would you know that? How in the world would you know
Cause
that?
it don't say it on there.
They don't say it on there, you never seen one. How would you know it? It's all right to say, what is that? I don't know what that is. That's what I would say. What is that?
So say it again, it's a reversing valve?
It's a reversing valve that we'll talk about much later. We don't need to go there. And, it's also called a 4-way valve because it's 4 pipes. 1 at the bottom, 3 at the top. Discharge at the bottom, suction the center, and heating or cooling stroke move on the right or left. We're not going there, that's too much right now. So what else you wanna know? What time you can leave or something?
Yeah, that's the next question.
So I enjoyed you. It's gonna be a journey. You're gonna get there. I see your faces. I know what I see. And we're gonna get there, and I probably will mix it up one day. We'll probably go to the lab and talk about some of these components on systems, so they make a little more sense to you. We can do that. Probably do that next class.
Alright.
You know, go in the lab and look at the components.
I don't know if you could you put the, like the sequence for the heat and air conditioning in the furnace, like on the sheet of paper you gave to us? Like you just put that on there, just write it down for me?
That's all we
I'll
doing.
make you guys down
Right now,
like
is that what you
I
were
want that
making?
down, but
Yeah,
I
that's
just,
how I used to give
you
myself.
might go home and forgot
Get
something.
your money.
we'll do it.
Glad you told me, boy.
Huh?
They sent me my ID.
I'm glad you told me, because I'm right behind you, boy. I got my ID too. Right behind you. Yeah, I'm going right.
Yeah, I think you do this for them.
You ready?
That's all I do.
Let me see what's up.
What y'all do?
Yeah, I got some. I got some of
You're
them.
gonna say